In this video, we'll focus on understanding distributions of numerical variables through visualizations. We'll look at how histograms give a visual representation of data and identify key features of data distributions, including center, shape, and spread. To understand categorical data, our basic approach is to count how many individuals are in each category. But numerical variables, because the data do not fall into neat categories but rather along a spectrum, require more sophisticated techniques and yield more nuanced observations. When considering numerical variables, we often want to know what values are common and what kind of variation there is in the data. To answer these kinds of questions, it's helpful to use frequency distribution visualizations, which plot how often different values in a data set occur. You've likely seen many frequency distributions before. They include histograms, dot plots, and stem and leaf plots. Here, we'll focus on histograms. In a previous video, we considered data from the annual Christmas bird count. Looking at the raw data, it's hard to get an overall sense of what the bird count looked like in Texas. A histogram provides a way to organize the data. Here, I've chosen to group the data into bins of width 10. The first bin goes from 150 to 160, the second from 160 to 170, and so on. The first bar has height 5, indicating that there are 5 sites that have a bird count between 150 and 160. We can check this. Here are all of those 5 bird counts. Whereas we can see that there's only one site that had a count between 220 and 230, and that's the 228 count. We can see from the histogram that the most common count was somewhere between 160 and 170, and almost all bird counts were under 190 species, but there were a few high counts above 200. A technical note on making histograms. I made a choice for what size bin I would use to make this. Using narrower bins would give more precise information, but it might make it harder to pick out general trends. Using wider bins makes a simpler visual, but you may lose important details. Once we have such a visual representation of numerical distributions, what do we want to learn from them? As with the bird count histogram, we generally want to know what values are common and what kind of variation there is in the data. To focus on these issues, we can identify the following key features. Center. What is the typical value in the distribution? There are some instances where there may be more than one, although in many distributions there is a single dominant cluster of values. Spread. How spread out is the data around the typical value? What is the variation in the data, and are there any data points that appear to be outliers? Shape. Is the data symmetric around the typical value, or is it skewed in one direction or the other? To highlight each of these ideas, I've created several sets of hypothetical exam scores. To contextualize the ideas of center, spread, and shape, it may be helpful to think about what would drive the exam score differences and what class you would want to be in. Shown is the first set for classes A, B, and C. For these 3 classes, the distinguishing feature is their center. For class A, values are clustered around 56. For class B, the typical value is around 59. And for class C, the typical value is around 66. Note that all 3 graphs are roughly symmetric around their center and have a similar amount of spread. Here's another set of classes, D, E, and F. For these 3, the distinguishing characteristic is their spread. The classes have a similar center. Exam scores for all 3 classes are clustered around 72 or 73. Also, all 3 are symmetric around the center. But the spread varies. As we move from D to E to F, there is more variation in scores in each successive class. Finally, let's consider the issue of shape. For these 3 classes shown, this is a key distinguishing feature. Class G is roughly symmetric, whereas the other 2 classes show significant skewness. We label the skewness by the direction of the tail. This means that class H is right skewed, whereas class I is left skewed. Let's apply these ideas to an example. As we've discussed earlier in the semester, water scarcity is an issue in the western U.S. Here, I've shared data from a survey on reservoir levels in several western states. To analyze the histogram, we can start by identifying the individuals and variable for the underlying data. Here, the individuals are each basin, lake, or reservoir that was surveyed. The variable shown is the percent of total capacity as of 12/31/98. This is a numerical value, variable, with percent as the units. Now we can use the histogram to better understand the data. Most commonly, reservoirs were around 80% full at the time of the survey. This is the center for the data. The levels ranged from completely empty to overcapacity at 110%, but the majority of reservoirs were between 30 and 100% full. We can also see that the distribution is skewed left. This reflects the fact that the levels are concentrated relatively close to full capacity, with fewer reservoirs with much lower levels.